it might seem like your attempts to swat a mosquito are in vain. But scientists claim that trying to squash a mosquito could help the blood-sucking insects stay away from you in the future. According to a new study, mosquitoes can learn to associate a particular odor with an unpleasant shock, such as being swatted. As a result, they'll avoid that scent the next time. The technique can be as effective as using DEET, one of the most popular mosquito repellents available. The mosquitoes remember the trained odors for days, says Jeffrey Riffel at the University of Washington, Seattle. It had been clear that mosquitoes don't decide whom to bite at random. They show obvious preferences for some people over others. They are also known to alternate hosts seasonally, feeding on birds in the summer and mammals and birds during other parts of the year, for instance. Riffel and his colleagues wanted to find out more about how learning might influence mosquitoes' biting preferences. As a first step, they trained mosquitoes by pairing the odor of a particular person or animal species with a mechanical shock. For the mechanical shock, they used a vortexer machine to simulate the vibrations and accelerations a mosquito might experience when a person tried to swat them. The insects quickly learned the association between the host odor and the mechanical shock and used that information in deciding which direction to fly. Learning in many animals, from honeybees to humans, depends on dopamine in the brain. Additional study showed that dopamine is also essential in mosquito learning. The research team found genetically modified mosquitoes lacking dopamine receptors lost the ability to learn. The researchers also glued mosquitoes to a custom 3D printed holder that allowed the insects to still fly in place while the activity of neurons in the olfactory center of their brains was recorded. Those experiments showed that without dopamine, those neurons were less likely to fire. As a result, mosquitoes became less able to process and learn from odor information. The findings may have important implications for mosquito control and the transmission of mosquito-borne diseases, according to the researchers. By understanding how mosquitoes are making decisions on whom to bite, and how learning influences those behaviors, we can better understand the genes and neuronal bases of the behaviors, Riffel says. This could lead to more effective tools for mosquito control. With this new understanding of how mosquitoes learn to avoid certain hosts, the researchers say they are now exploring mosquitoes' ability to learn and remember favored hosts. In both cases, we think dopamine is a critical component, Riffel says.